Okay, hello everyone. Thank you for attending, and thank you, Jet, for inviting me to give this talk today. So my title is Cloud Native Geospatial in Modern GIS Education, and I send the links to my slides in the chat. So you're welcome to access the slides. So here's the outline. First, I'm going to briefly talk about the Open Geospatial GitHub organization, and then we showcase some of the packages that I have developed, including Geemap, Leafmap, and also some interactive web apps that makes it easy for people to access data and visualize data. And lastly, I will show you some educational resources that I have developed that might be useful for the people that want to learn some of the open source geospatial technologies. And so Open Geospatial Solutions is a GitHub organization that I created last year. So the idea is to basically create a community that allow people to share some of the projects. And I moved some of my project from my personal GitHub account to the organization. And so basically the idea is to make it more sustainable. So if one day that I no longer exist, people can continue because they have access to all the repo and they can continue to develop the packages. And here is some of the things that I have created, including mostly Python packages, but also have some data catalog because we have lots of data, open access data, but not everyone know how to access the data, especially for people don't have the geospatial background or don't have very limited coding skills. We need to make some of these things more accessible to them, and also in terms of the web app, how do we make things that easier so that users just need a browser, they don't need to create a notebook or anything, and then they can still access some of the open geospatial data. So anyone is welcome to contribute to join the community. There's only like 2,000 followers. It's just a small community, but anyone is welcome to, if you want to contribute to your project, you're welcome to contact me, and then we can help you put your project on the GitHub organization. So the first package I want to highlight is a Geemap. So Geemap is a Python package for doing geospatial analysis and visualization with Google Sensing. So Google Sensing is a very popular cloud computing platform for doing large scale data processing. And I created a project, I think around 4 years ago, right after pandemic. At the time I was teaching my students how to use Google Sensing. And at that time, the Python API is very limited, that they don't have a lot of visualization functionality. So I learned some open source packages, including Folium, IPyLive there, and IPyWidget, and makes it easy for my students to learn how to use Google Sensing. And then I put it on GitHub, so people like it, and so I continue to develop and maintain. So since last year, Google Sensing team has officially adopted Geemap as the Python package, and then you can find it on documentation. So now it's very easy to actually use because it has been pre-installed in Google Colab. So you don't need to install the packages anymore. You can just open the Colab notebook and then you can just start doing cloud computing. So next, I'm going to quickly show you some of the key features. For example, you can, the Google Sensing has over 100 petabytes of data. So you can easily source any data using the Geemap interface, any keywords, and then you can just click one import, and then you will be able to access the data, visualize the data, without having to download anything. So kind of like you are watching a movie, searching a movie on Netflix or YouTube, you will be able to actually visualize the data directly, and over 100 petabytes of data. So you can just at your fingertips. It also includes support for the Earth Engine GE community data catalog. So that one also has, I think, couple hundred terabytes of data. And it's very powerful that if you need to see the data, this might be the easiest way that you can explore the data. You can also visualize data interactively, so similar to desktop GIS. Geemap provides those functionality, allow you to load the data, and then you can change the customization, change the visualization, whether it's single raster, a single band raster, multi-spectral band, or it's a vector data set, you name it, you can do it easily. So the idea is to make it easier for people with limited coding skills, or even if you are very experienced, you can still enjoy some of this interactive functionality without having to worry about like how to write the code to do that. And more recently, I added some of the 3D visualization functionality. So you can actually combine Google Sensing data with some of the open access data, for example, over to a building data set. So you can overlay that on a single web interface, so that you can basically moving away from 2D visualization to more better looking, nicer, like 3D visualization. And also you can integrate, for example, Mapbox, the 3D globe. So that's also possible. So you can, for example, overlay the European Space Agency, the global land cover on top of that, and you can visualize this also JPEG on the 3D terrain, this is something you want to do. And one of the things that I really like is that Google Sensing has the capability allows you to access large amount of data and then do the computation very easily. So one of the popular applications of Geemap is creating time-lapse animations. So you can basically go to anywhere around the globe, simply draw a bounding box, then you can create animation in 20 30 seconds. And you can change the band combination, you can define different area, you can create animation by year, by quarter, by month, whatever you want, as long as the data has that kind of temporal frequency. And this would not be possible. This used to take like hours or days to create because you need to download the data, you need to do pre-processing to remove cloud and then to mosaic them. But now people without coding skills, they can actually see changes of the landscape and then download the animation easily. You can also run analytics. So you can run large scale data processing and you can create this kind of plots easily, and then you can use that in your report or your publications. And more recently, there's some like AI integration. So you can right now use a text prompt, just like ChatGPT. You can ask, for example, I want to visualize the DM using Geemap for certain area, something like that. You will be able to generate the code examples. And then so all you need maybe do some minor changes, and then you should be able to access the data. So this really makes it accessible because not everyone know how to do coding, and you can just create the coding examples, and then you can access that directly within a notebook. You can also export the data. So there, like I said, there are 100 petabyte of data. So you can actually ask, for example, show me the DM, for example, over Australia. You can change the customization, and the model also be able to actually interpret the map. So based on the images that being generated, so you'll be able to understand, for example, where is this location and what's the color, something like that. So there are a lot of things that we can integrate into this kind of platform utilizing the large language models. Also the data asset explorer. So you can actually source data. For example, if you are new to geospatial or you don't know what data set to use, you can simply ask, for example, how much the global land cover, land temperature has changed, right? And then you will recommend some data set, and you will know whether this is suitable for doing this kind of task or not. Either it's temperature, forest, surface water. So there are tons of applications that right now that we can potentially utilize this kind of platform to do scientific research. And I also published a book last year that introducing Google Sensing and also Geemap is open access. So you can check out the link upper right corner there if you want to learn more. And I would like to acknowledge the funding from NASA and also Google for supporting some of the work that I'm doing. So that's about Geemap. And the next one is Leafmap. So Leafmap was created 1 year after Geemap. So basically Geemap is designed for utilizing Google Sensing, but there are also other cloud computing platform. For example, previously the Microsoft Planetary Computer and also AWS and also a local notebook or your custom Jupyter Hub. So Geemap basically utilize those interactive functionality, but makes it more applicable to any open data and also cloud computing platforms. And again, it's open source. You're welcome to check that out. And Leafmap support a variety of mapping backends. So the idea is that makes it easy for people to do mapping, so you don't have to learn all these mapping libraries. So Leafmap try to provide a unified API. So the same line of source code, the only thing that's different is just the first line. So either you import a different mapping backend, kind of like ChatGPT, like the large language model. You can use ChatGPT, you can use a Gemini, you can use whatever you want. The idea is that you don't have to worry about all the specific about those, and then you use the same API to do that. And so Leafmap provides some functionality that allows you to source those open access data. So for example, from Microsoft Planetary Computer, right, they also have a data catalog. So you can use the Leafmap to easily source data for any location. So simply just draw a rectangle and then use the interface. You can source the data, you can visualize the data using the T-Tiler endpoint, and then you can also download the data for doing computation if you want to. So this interface is useful for users that just want to look at the data, and then you don't have to worry about how to do the coding. And also, for example, you can also source data from AWS Open Data Catalog. So some of those data has the STAC endpoint. You can easily source the data, and also you can visualize the data using, for example, T-Tiler. And so, for example, in this case, showing you how to source the Sentinel-2 dataset, right? You can just draw a rectangle, and then it will show you all the dataset meeting the criteria, and then you can just simply one click to visualize the data without having to worry about writing the code. And you can change the bank combination. You can also download the data. You can also, because you have the pointer to the data, so you can use that to do analytics, extract water, urban, something like that. The other data catalog is the NASA Earth data. So it also has hundreds of petabytes of data. Not everything is available through other platforms. For example, Google Sending or Microsoft Printed to Computer. And this may be on top of Earth Access that allows you also to source data interactively for the entire NASA Earth data catalog. So you can easily figure out the footprint. And I'm also trying to support to add some functionality that allow you to directly visualize the data, so you don't have to download the data. And this really makes it easy for people to basically access geospatial data. More recently, there's some a lot of development in the overture data set. Also, a couple talks have already mentioned this. So Leafmap also can visualize the data in 3D, for example, just one line of code, basically create a map, and then you can add the overture or 3D buildings. And so using the PMTiles hosted on AWS, you can just create like this kind of map, and then you can just export as HTML. You can click the link on the lower left corner. You can actually try out the demo yourself. It's really fast, and thanks to all the open, so the cloud native format PMTiles, and also, for example, cloud optimized GeoTIFF and also STAC catalog. And you can visualize any data from Overture. So all the different themes, transportation, address, base, division, they're all supported. So one line of code, you can put the data into Python environment, and then you can use that to combine with other data layers, so you don't have to like create multiple platforms. And the most recent one that I added in the Leafmap is the field of boundary dataset, also hosted on Source Corp. And so it's really nice dataset that useful for doing machine learning and also deep learning to train the model. So Leafmap can also visualize that just with couple lines of code. So there are a lot of ways you can customize the visualization. So every demo that I'm showing here, there's a notebook, so everything is reproducible. So you're welcome to try out the notebook, and you can customize the visualization to your liking. And lastly, most of the cloud optimized format, for example, code stack, you can visualize it using T-tiler or also local type server. So it depends on where you are running the data, whether it's accessible through HTTP or not. And again, everything is pretty much 1 to 2 lines of code. You can add raster, add code layer, and then you can visualize the data. You can combine with some like 3D functionality to visualize them if you want to. And the last one is GeoParquet. So Leafmap also support the visualization of GeoParquet data, and you can also utilize the longboard, or you can convert GeoParquet to GeoData frame or GeoJSON. Then you can visualize them using Leafmap. So some of the data set that I put on the source code, for example, the national wetlands inventory. So you can pull the data, you can run analytics using DuckDB just with a couple seconds. So this used to take me hours actually to run analytics at the national scale, but with DuckDB now it takes a couple seconds. You can get the result pretty easily. So it's very powerful. So these are some of the things that have been integrated into Leafmap that makes it easy for people to utilize this. And I would like to acknowledge this the support from Amazon for some of the work that I'm doing, especially Leafmap and also Segment Geospatial. Besides creating those tools, make it easy for people to use, I also want to really make it more accessible for people, for example, non-geospatial people or people don't have coding skills. So I developed some of these web apps that allow anyone to access those data. So for example, you can develop the application using Solara, and also, for example, deploy on PyCafe. So this makes it really useful for teaching, because not everyone has know how to set it up or to be the notebook or create a notebook. Although we have Google Colab, but still you need to have an account, you need to install the packages. It takes time. So PyCafe is also a very nice platform that you can use for teaching, and you can develop the app, and then students can actually make changes on the fly. So they don't have to install anything. So it sets up, syncs up, and then they can run the code, they can modify it, and then you can render the data set easily. So another web that I created is, for example, visualizing some data, Maxar open data hosted on AWS. So whenever there's natural disasters, Maxar release some of those high resolution data on AWS. But again, not everyone know how to access that or visualize that. So I created the app using Solara and deploy on Hugging Face. It's all free, it's all accessible, so anyone can utilize that to quickly see some of the changes. So this is for the flooding in Libya last year, and also more recently, Hurricane Helene and also Milton. Like you can easily utilize these kind of web apps to see the changes. And you can download the data, of course. You can do analytics using some of the AI and also machine learning. But before you can do that, like at least you need people need to see where are the changes and visualize the data. I think it's the first step before you run any models. Also, the other one is the Global Surface Water Explorer. So this one I created basically utilizing Google's engine Geemap. So it makes it easy for people to visualize data and to run some simple analytics. For example, you can create animation, just one line, no coding, pretty much. Go to the URL and then you can draw a rectangle and then you can create animation 20, 30 seconds using the entire Landsat archive, with over 40 years. And you can do it for anywhere. You can do it using any bank combination. You can also access the original data. So if sometimes if you don't want the animation because it's a small coarse resolution sample, if you want to access original data, you can also do that using the interface. So you can change the start year and end year, and just one click, now you have access to the original Landsat data, and you can see it, you can zoom in, you can zoom out, you can compare them side by side, so you can clearly see the changes. So I think this is very important for people, non-geospatial people, no-coding people that want to see some laws, but they were not able to because they don't know how to set things up. But with this kind of a platform, it makes it easy for them to do that. You can also run, for example, computation. It's not just getting the original data, the power of the cloud computing and cloud natives that you can actually run analysis on top of that. So for example, I'm focusing on water. I can simply draw a rectangle. We can use the data set to, for example, analyze the water accounts. Just within a couple of seconds, you can see whether this is permanent water or just temporary water, or what's the water, basically the history of the water. And you can also, because the data catalog is being updated constantly, so you have access to the real-time data. For example, this is a flooding happened in China a couple of months ago, right? So you can use the web quickly to see all the data set available before and after the events. And that is not limited to just one event. You can do that anywhere. So basically, makes the Landsat data much more accessible. So anyone can just go to the web app and then just click a couple buttons. And you can also extract water, for example, just do a simple thresholding on the surface water index, and then you can quickly figure out what's the flood area, and then you can basically use that to guide your disaster response. So try it out the web app, and you can customize it, you can clone, you can use it for adapt it to other applications. And lastly, I want to show you some resources. So I'm a faculty at the university, so I teach every semester, and all my teaching and the materials are all open access online. So I created a lot of tutorials. You're welcome to check out the YouTube channel. So this is the course that I'm teaching right now. My student how to do GIS programming, intro level, introduce some of the most popular one. And also all the videos are online where anyone welcome to follow if you want to learn how to utilize some of this cloud native geospatial. And the other one is spatial data management, introducing, for example, Google Sending, DuckDB, PostGIS, and there are a lot of novel examples there. And again, there's a whole course of DuckDB for geospatial. And the last one is geographic survey design, teaching students how to build packages from scratch. Basically, how I build Leafmap, Geemap, and introduce all the practical tools that can be useful for doing cloud native geospatial. Okay, that's all what I want to share, and happy to take any questions. You're welcome to connect with me on social media.
Thank you, Qiusheng. That was awesome. Let's see if anyone has a quick question, but then we'll just start transitioning to STAC. Is there any plan to combine these functionalities with SAR analysis for any data?
Yeah, certainly. It's just like most of those for data visualization. In terms of analytics, you can use any Python package in combination, and then you just visualize the result. You input your output. But certainly, if there's a particular needs that you want to see, I can add some functionality in Leafmap that makes it easy for you to do that. Or even it's Geemap or Leafmap, right? You can just one line, for example, extract water using Sentinel-1 or something like that. That's certainly feasible. Yeah.
Awesome.
Mhm.
Cool. Well, let's transition to
Okay, thank you.
Thank you again.
Mhm.
Bye, everyone.